Hello everybody. Today we are going to start a new topic called the Pythagorean Theorem. This theorem relates the lengths of three sides of a right triangle. So, I am going to start by drawing us a right triangle. And please make sure this is written down in your notes. Oops, I'm going to redraw that. That does not look very good. So yes, make sure this is drawn in your notebook. This will help you when solving these types of problems, so you can go back and look at them if you get stumped on a problem. Now we are going to label this triangle so you understand where the actual Pythagorean theorem equation comes from. So we're going to start with the legs of this triangle. Now we're going to label the two legs A and B. Now it didn't matter if you put B here or A here, it doesn't matter. What does matter though is the C, which will be the hypotenuse, which make sure you fill this in so you know. So we have your hypotenuse, and then I'll label A and B as our legs. So remember, A and B are interchangeable. It doesn't matter which order those go into. Now, here is the equation that's going to be essential when solving these types of problems. We have a squared, so the length of one leg squared, plus b squared, which is going to be the other leg squared, is going to equal your hypotenuse, or your c squared. So make sure you have these all written down in your notes, and we're going to do some examples along with a story problem that will help you guys when we get further along in this section. Now feel free, you can pause this at any time if you need to go back, you need to copy stuff down. That's okay. Just make sure it's all written down so I can make sure that you watch the video. So, we're going to start with an example here. We have a right triangle, and we want to find C. So this is our goal. Now, so C is our hypotenuse, and then our legs are given to us as lengths 12 and 5. So remember, our equation is going to be a squared plus b squared equals c squared. So now all we basically have to do is plug in and solve. It's pretty simple. Just make sure that you're putting the numbers into the correct spots. And like I said, you can interchange your legs. So you could have put the 12 here and the 5 down here. It does not matter. So I'm going to put the 5 in as my a squared. So we're going to take 5 squared plus, and then my b squared will be the other leg, which would be 12 since I already used the 5. That's going to be squared. And we don't know our c. That's what we are looking for. So this is just going to remain c squared. Now, all I need to do is solve and simplify. So I have 5 squared, which will give me 25, plus 12 squared would be 144, and then the c squared is just going to come down since that's what we're looking for. Now if I add 25 and 144, that is going to give me 169. And then c squared still comes down. Now we're almost done. We want to get c by itself because that's what we're looking for right here. Well, you can see the c has a squared on it, so we need to get rid of that. And all we need to do to get rid of that is square it. Well, since this is an equation, it's an equality with the equal sign, what we do to one side, we have to do to the other. So then we also have to square root the 169. So we have c equals, and if you use a calculator to do this, you type in 169, take the square root, you will get the answer of 13. So that is exactly how we find the c. Now if you were to go plug back in each length, your leg, both your legs and your hypotenuse, back into the original equation, your left side, a squared plus b squared, should equal your c squared. Let's do another one. So once again, I'm going to draw my right triangle. This time, we are going to have to find the missing leg. So we want to find the missing leg. So we're going to say our hypotenuse is going to be 15. And then we're going to call this leg over here the length of 9, and we want to look for this side. Now, normally you could call this b. Sometimes you may see a different variable. They could call it x. It does not matter. So once again, we're going to use our equation a squared plus b squared equals c squared. And then once again, we're going to plug in. Now I'm going to use this leg as my a squared. So basically, I'm going to plug in x squared. And if you were to put a here, you could have done a squared here instead. It does not matter. And then my b squared will be my 9 over here, since that is the leg we have not used yet. And then my c squared is going to be my hypotenuse squared, which will give us 15 squared. Now we're going to have to do one extra step on this problem. So we have x squared, since that's what we're looking for, plus 9 squared, which is 81, equals 15 squared, which is 225. Now I need to subtract the 81 over to solve, which that's going to cancel, so I'm left with x squared equals, and if I solve 225 minus 81, I should get 144. Now one more step and we will have the length of our missing leg. So remember, like the last problem, we're going to have to take the square root of both sides to get x by itself. So if you type into your calculator the square root of 144, we will get 12. Alrighty, we are going to do one more example. It's going to be more of a story problem. So, I will present you with the story problem and then we'll work through it together. Alrighty, here is our problem. I'm sorry about the handwriting. I will read it to you. A 35-foot ladder is leaning against the side of a building and is positioned such that the base of the ladder is 21 feet from the base of the building. How far from the ground is the point where the ladder touches the building? Okay. So like I said, you can pause this if you need to kind of grasp what we're doing here. But I am going to draw a picture so we can label this and see what they are actually talking about. So remember, we have our building. Bear with me, I'm not an artist. And then we also have our ladder. Okay, so there's my ladder leaning up against the building. Now, in the problem it tells us that the ladder is 35 feet long. So, that is going to be where I label the 35, where the ladder is. Now it tells us that the base of the ladder is 21 feet away from the base of the building. Well, the base of the building is right here, so that means this length is 21. Well, as you can see, the ladder leaning against the side of the building forms a right triangle. So this is perfect to set up just like we did in the other example problems. So what we're going to be looking for is this missing leg. We want to know how tall is the building. Alrighty, so we're going to start with our equation again. A squared plus b squared equals c squared. Now I'm going to let my x be plugged in for a squared. So I get x squared plus my b squared would be the other leg, which is 21. We're going to square that. And then my hypotenuse, which is 35, or the length of the ladder. Now we are going to solve just like before. X squared stays there because that's what we're solving for. 21 squared gives us 441. And bring down our equal sign. And 35 squared is 1,225. Now we need to solve. We're going to subtract 441 from each side. So that cancels on this side. So we are left with x squared equals 784. When you do the math, you get 784. Now one final step, we're going to square root both sides. X squared becomes x, and the square root of 784 is 28. Well, if you look back at the original problem, they label the lengths in feet. So we're going to make sure that we label our answer too. So that means that the x length over here is 28 feet. Now I hope everybody got everything written down. Make sure you have this in your notes and be ready to turn in to me. And we will continue on this in class tomorrow. Thank you.